Some of these are some of my favorites to think about. I had the square root of x to the 5th, y to the 13th, y to the 7th. And I want to reduce that. Well, the first thing I want to do is think about just each term individually. X is by themselves, y is by themselves, and z is by themselves. So I'm going to try to figure out what's the best factor of x to the 5th that's a perfect square. And I'm going to leave it as x to the 4th. Y to the 13th, that's going to be y to the 12th times y. And then z is going to be z to the 6th times z. Maybe it doesn't make sense right now. Why did you choose those particular factors? Why did you choose something else? Well, follow along with me and we'll see what happens. I have the square root of x to the 4th. I'm going to break them up into their individual square roots now. Square root of x to the 4th times the square root of x. Square root of y to the 12th times the square root of y. Square root of z to the 6th times the square root of z. What's the square root of x to the 4th? X squared. Square root of x, I'm going to put him over here. Basically, he stays in jail. He didn't have enough bail, enough x's to kind of release him from jail, so he's going to still be behind. However, the square root of y to the 12th, well, that's y to the 6th, because y to the 6th times y to the 6th equals y to the 12th. So the square root of y to the 12th is y to the 6th, and what's left over? A y. And then the square root of z to the 6th, z cubed, with the leftover z. So my final answer is, or my final solution where everything's been reduced, is x squared, y to the 6th, z cubed, square root x, y, z.